All right, welcome function folks. This is lesson 2.0, prerequisite skills for unit 2, which is our unit on rational functions. And I'm guessing that we're going to have a lot of flexibility in the next couple of days leading up to or just after the polynomial functions and equations test. This lesson is about 1 day's worth of work, 2 little part lessons where you're doing most of the work. I am just taking this stuff up. This is the plan here. So you should have done this sheet yourself, or with a partner, of course. If you're watching this video, this will take up this sheet, and then after that, there's a prerequisite skills activity that you should do in class with partners. And then there'll be a take-up video. So there'll be 2 different videos that take up this material. It's about 1 class worth of work, but in there you're probably still reviewing and planning on writing the test very shortly too, along with some homework. So that's the plan. If you haven't tried this sheet yet, you shouldn't be watching this video. All right, on we go. Essentially, you read this and you get a relationship between volume and pressure of a scuba diver. So it says here the original volume in the lungs is 4 and the original pressure is 1, and then you divide by the new pressure, and we see that as we go down each 10 meters the atmospheric pressure goes up by 1, right? So then if I'm coming up with these relationships, this is just a pattern, right? So you just write those in, and then this is the volume of air in the lungs in liters. Basically, it's the original volume times the original pressure, that's where the 4 comes from, divided by the new pressure, which was 3. So 4 divided by 3, 4 divided by 4, 4 divided by 5, and so on. This is a setup question for the next one. The next one is a diver takes a 4-liter breath of air 60 meters down, right? 60 meters down, remember the pressure was 7, and I'm kind of starting this table over here, and hopefully you got these values, because now the original pressure was 7 and the original volume was 4, and as we go up, what happens to the volume of air in the lungs? Well, it goes up as well. By the time we get to the surface, there's 1 pressure and the volume of air in the lungs isn't 4 liters anymore, it's 28 liters. It says, using the answers from the above table, find the relationship between P and D. And this is kind of a guess and check thing. There's 2 possible formulas you could have had. You saw that the depth is related to the pressure. It's if you subtract 1 and multiply by 10, or some people say you take the depth and you divide by 10 and add 1. Either way, you get this relationship between depth and pressure. So hopefully you got one of those, and you can check it using the various values there. Dandy. Using the answers from the above table, find the relationship between V and P. So if we look, V and P here, V and P, if you notice, they always multiply to get 28. V and P always multiply to get 28. Original volume, original pressure, V times P is 28. So we got V equals 28 divided by P. And then it says use algebra to show that that's true. Well, we got 2 different formulas. Essentially, all we have to do is combine them. Volume is 28 divided by P, but P is this other formula I substitute in, and a little bit of, collect like terms there, dividing a rational expression. Remember from grade 11, you flip and multiply. So, Mr. Resdell, I can't remember that. Well, that's part of the review, review and preview for the chapter. And then we multiply fractions across and we get the expression we're supposed to get. Then it asks us to use the graphing calculator, and you can do this without the graphing calculator. There's a sketch right there, right? You can plot the points in red here, and then draw the graph. The green dots are coming up later. Remember, if I'm going too fast, you can pause and make corrections. Look at your table and your graph and decide through what depths the diver should be most careful about breathing to avoid bursting her lungs. It says from 10 meters, 20 meters to the surface. No, notice from 20 meters to the surface, 60 meters down, she took a breath, and that was 4 liters. But as she gets close to the surface, look how fast the volume in her lungs are increasing. Quite quickly, as the depth, as she gets closer to surface, she needs to sort of reset the volume in her lungs by taking a breath. And this is the idea of, I don't know if we have any scuba divers in the crowd, but they say if you don't, you have to watch you don't come up too fast or you'll get the bends. And that's what this is about. What happens to the graph as the depth increases? As the depth increases, well, as D goes to infinity, the volume goes to what? 0, right? This is an asymptote, right? We talked about that a little bit already, not much, but back in unit 0 we talked about asymptotes, but this is an asymptote, right? This is the end behavior of that graph. What happens to the graph as the depth moves into the negative values? Well, we see that it's increasing quickly and quickly, that in fact, as if she was at the surface and then got, climbed a ladder, that her lungs would get even bigger and bigger. And we know that the formula here, which was volume equals 280 D plus over D plus 10, that mathematically, if D is minus 10, on the bottom we're dividing by 0, which we can't do it. There's a restriction. And we can see that as D goes closer to negative 10, V goes to positive infinity. Again, this is an asymptote, right? This time a vertical asymptote. All right, and that's sort of things just to plant some thoughts into our mind here. That was me taking up that sheet. This the next part of the prerequisite skills is an activity that you will do in class, and the next little tiny video will take that up.